Welcome to Unit 2, Part 2, The Structure of Sentential Logic at George Mason University, Phil 173, Distance Learning Module, Instructor Kirkendall. Yes, Kirkendall, not Kuykendall. It's a Dutch name. That's how it's pronounced. Well, we've been talking about simple and compound sentences, which are basically the elements, some of the elements in arguments, which is what this class is, basically about. Well, we're going to continue studying sentential operators. Now, also recall that we said that while there is an infinite number of sentential operators, there's only going to be 5 that we're interested in for a while. And, either or, if then, if and only if, and the negation. Now, also recall that sentential operators are what combine simple declarative sentences into more compound sentences. So compound sentences are those made out of simpler sentences, and kind of what allows us to construct these compound sentences, these sentential operators. So we should get to know these better. We should be familiar with them. So, to kick it off then, sentential operators are what combine simpler sentences into more complex sentences. We'll define a sentential operator as follows, and this is how the book defines it, and then we'll go with it. A sentential operator is an expression containing blanks such that when the blanks are filled with complete sentences, the result is a sentence. Again, a sentential operator is an expression containing blanks such that when the blanks are filled with complete sentences, the result is a sentence. Here's some examples. It is possible that blank. For example, you could say it is possible that it is raining. It is possible that my backyard's got mud puddles in it. It's possible that I am hungry. It's possible that it's the year 2016. It is necessary that, it is likely that, it is not true that, either blank or blank, and you can insert sentences in the blanks. Either it's snowing or it's raining. Neither or nor. It's neither snowing nor raining. Blank and blank. It's snowing and it's cold. If blank, then blank. If it's snowing, then it's cold. If blank, if and only if blank. If it's snowing, if and only if it's cold. Blank unless blank. It's raining unless blank. The sun's shining. Blank after blank. 2010 is after 2009. So, of course, we want sentences in here. So how about the month of February is a great month. Never mind, I give up. Blank only if blank. It's snowing only if it's cold. Blank because blank. It's snowing. Blank. It's snowing because it's cold. You get the idea. Well, operators with one blank are appropriately called one-place operators. Operators with 2 blanks are called two-place operators. Operators with 3 blanks are called, I bet you can figure it out, 3-place operators. Good, you're a genius. All right. As I said, though, we're only concerned with 5. And I'll go through them, and we're going to spend some time in each of them in this video lecture. First is the conjunction operator, blank and blank. Second is the disjunction operator, blank or blank. Third is the conditional operator, if blank, then blank. Fourth is the negation operator, not blank, or it is not the case that blank. Finally, the biconditional operator, blank if and only if blank. Let's start with the conjunction operator. Well, literally, the conjunction operator is that little word and. And with that word, you can combine simple sentences. It's snowing and it's cold outside. George Mason University is in Virginia, and Virginia is in the United States. Chicago is in Illinois, and the Cubs play in Chicago. Davis is the instructor for Phil 173, and Davis is awesome. You get the idea. So, and is basically a conjunction word. It's not the only word. It's not the only word that stands for conjunction. As we'll see later on, there are other words that fall under the conjunction operator. It's broader than the word and, but for right now, we'll just use the word and. And it's symbolized with this dot right there. I guess I'll use the pen. And we'll go with green. That dot right there is the symbol for the conjunction operator. So when you see that, that means, well, it means the word and. It means that there's a conjunction. There is a Schoolhouse Rock, which I won't show the video for. It's a conjunction, junction, what's your function, hooking up words and phrases and clauses. That's literally what it does. All right, here's an example. You've seen lots of these. Dogs eat dog food and cats eat cat food. Two simple sentences, simple sentence 1, simple sentence 2, combined into a compound sentence, sentence 3, via the conjunction operator. Isn't that amazing? All right, now there's the disjunction operator. The two major components of the disjunction operator are disjuncts. Unlike the word adjunct, which is what I am, an adjunct professor at George Mason University. Always got the word junct in it, just like conjunction as well. All right, so it's literally the word or, blank or blank. It's symbolized, however, with this thing that looks like a V. So it's either the word or it's this V symbol. The V is the disjunction. The dot is the conjunction. So when you see a V, that means disjunction. Blank or blank, okay? An example, again, dogs are mammals or dogs are reptiles. Two simple sentences, sentence 1 and sentence 2. Via this disjunction operator, they form the compound sentence 3. Sentence 1 and the disjunction of sentence 1 and sentence 2 results in the compound sentence 3. And in compound sentence 3, sentence 1 and sentence 2 are both disjuncts. So the conjunction operator and the disjunction operator should be pretty easy to understand. We don't need to spend too much time on. The conditional operator, on the other hand, we will spend some more time in, not necessarily in this unit, but soon. In the next unit, we will be spending a fair amount of time. But for now, we just need to understand the symbolization for it. So it's also a two-place operator. If blank, then blank. And the symbol for the conditional operator is this horseshoe shape thing. It's the horseshoe symbol. Some logic textbooks will use kind of an arrow, like that. Our logic textbook uses the horseshoe. All right. So it's if blank, then blank, or blank, horseshoe, blank. That's the conditional operator. And here's an example. If dogs are mammals, then dogs are living. Dogs are mammals is a simple sentence. Dogs are living is also a simple sentence. Via the conditional operator, which we're using the English words now, but we could also use a horseshoe, you get sentence 3. Okay? That's how you construct it. Pretty cool. All right. The two major components of a conditional are the antecedent and the consequent. The antecedent goes to the left of the horseshoe. The consequent goes to the right of the horseshoe. So again, the antecedent goes to the left of the horseshoe. The consequent goes to the right of the horseshoe. And these are the two components of a conditional. Antecedent, ante is the Latin word for before. And it goes before the horseshoe, so it's appropriately named. Consequent, well, you know, a consequence is something that happens as a result of something else. So it means kind of like it follows from. So the consequent follows from the antecedent. Appropriately then comes after the horseshoe. Question then, where is the antecedent and what is the consequent in this example right here? If dogs are mammals and dogs are living. Is 1 the antecedent or is 1 the consequent? 1 is the antecedent. Is 2 then also an antecedent or is it a consequent? It's a consequent. If antecedent, then consequent. If dogs are mammals, then dogs are living. Okay. Relatedly, there's the biconditional operator. Blank, if and only if, blank. It's also a two-place operator. Blank, if and only if, blank. 1, 2 places. See? All right. The symbol for the biconditional is this triple bar. It's like an equal sign with one more line, all right? So the biconditional operator is not this is not the same thing as the equal sign. All right? That's the biconditional operator. That's an equal sign. They're not the same thing. So when you see the 3 bars, that means if and only if. Example, Luke is Leia's brother, if and only if Luke's parents are Leia's parents. All right, again, Luke is Leia's brother, if and only if Luke's parents are Leia's parents. All right, if Luke's parents weren't Leia's parents, then Luke wouldn't be Leia's brother. All right. And there's no special names for what goes in the left or the right of a biconditional. So, poor biconditional. But you get the point. Sentence 1, Luke is Leia's brother. Sentence 2, Luke's parents are Leia's parents. Via the biconditional operator, you get sentence 3. Ta-da! All right. Finally, let's look at the negation operator. It's that English word not. All right? And it's symbolized in a logic textbook with this tilde, which you find on your keyboard. And here's an example. Spock is not a Jedi. He's a Vulcan. Vulcans can't be Jedis. That's obvious. All right. So again, when you see a sentence with a negation in it, it's actually a compound sentence. And then if you remove the negation, whatever the you get this simple sentence without a negation. So Spock is a Jedi would be a simple sentence. Not would be, well, we can make it say, it is not the case that, which is another way of saying not. And then, it is not the case that Spock is a Jedi. That's another way of saying Spock is not a Jedi. All right. Okay, so in addition to the sentential operators, we also want to find a way to symbolize sentences in sentential logic. So the simplest formulas in symbolic logic, and the ones which we'll spend a lot of time with, will just be simple single capital letters that will stand for simple non-compound English sentences. And then we'll combine these via sentential operators into more complex compound formulas. And that's all we'll be working with for now. But so in addition, so that's the kind of second set of symbols that we're going to be dealing with. There's the first set of the symbols for the operators, and the second is the symbols for the sentences connected via the operators. Well, the standard practice in sentential logic is to just take, the first letter of the sentence and use that to symbolize a whole sentence, or a letter that's kind of unique to that sentence. So we're just going to take 4 sentences and we're going to symbolize each of them. Let G symbolize the sentence, "The Golden Girls is the greatest TV show of all time." And then you notice that we use G because, Golden Girls, it's a letter you find throughout the sentence. Let B stand for Betty White starred on the greatest TV show of all time, which, by the way, was The Golden Girls. Let M equal Matlock is the greatest TV show of all time. And then let A equals Andy Griffith starred on the greatest TV show of all time, which, by the way, would be Matlock. All right, so we've just got 4 letters, which will each stand for a simple sentence. G, B, M, A. Well, we can combine these letters via the sentential operators to make more compound formulas. Let's do that right now. So here are 4 formulas. G dot B. Remember what dot stands for? Remember? It means and. It's a conjunction operator. All right. So G stands for the Golden Girls and B stands for Betty White. So G and B. The Golden Girls is the greatest TV show of all time, and Betty White starred on the greatest TV show of all time. That's what that sentence means. All right, now we have this B and then this symbol here in A. Remember what that symbol means? It means or. It's the disjunction operator. B or A. Betty White starred on the greatest TV show of all time, or Andy Griffith starred on the greatest TV show of all time. That's a disjunction. Okay, M, then we see these triple bars, and then A. Well, what's the triple bar? It means if and only if. It's the biconditional operator. And it takes a long time to write with this pen. All right. M, if and only if A. Matlock is the greatest TV show of all time, if and only if Andy Griffith starred on the greatest TV show of all time. All right, finally we've got this horseshoe. What is that horseshoe again? That's the conditional operator. The horseshoe means if, then. All right. If Matlock is the greatest TV show of all time, then Andy Griffith starred on the greatest TV show of all time. So those are 4 compound sentences symbolized with single capital letters standing for sentences, and these are also the symbols for the various sentential operators used in symbolic logic. All right. Well, you negate a simple formula by placing a tilde in front of it without using parentheses. All right. And this should be reviewed. For example, tilde A means Andy Griffith did not star on the greatest TV show of all time. It is not the case that Andy Griffith starred on the greatest TV show of all time. Tilde A. That means it is not the case that, and then that sentence. It is not the case that Andy Griffith starred on the greatest TV show of all time. All right. Well, here's another thing you need to know about compound formulas. Oftentimes, we're going to require parentheses. And parentheses will actually affect the meaning of the sentence. All right. So for compound formulas, parentheses are required. For example, what's this right there? Tilde parenthesis B dot A parentheses. It means it is not the case that Betty White starred on the greatest TV show of all time and Andy Griffith starred on the greatest TV show of all time. That's a negation operator. That's a conjunction operator. It is not the case that Betty White and Andy Griffith both starred on the greatest TV show of all time. All right. Now, these parentheses are important. Okay, let's think about this. We'll call this sentence 1 and we'll call this sentence 2. These are not logically equivalent, all right? This sentence says it is not the case that Betty White starred on the greatest TV show of all time and Andy Griffith did star on the greatest TV show of all time. But in other words, it's saying that it's false that Betty White starred on the greatest TV show of all time, but it's true that Andy Griffith starred on the greatest TV show of all time. This sentence says it can't be true that Betty White, B and A both can't be true. That's what 2 is saying. It can't be true that Betty White starred on the greatest TV show of all time, and also true that Andy Griffith starred on the greatest TV show of all time. Okay, so this is not, it's not equivalent to that. That'll make more sense in Unit 3. We'll get into, and as we go into truth tables. So don't rack your brain about this too much. I could spend an hour explaining the difference between the two. But the point is, though, the parentheses make a huge difference to the meaning of these sentences. All right? These are not the same sentence. This tilde is negating this formula. This tilde is just negating this simple sentence, whereas this tilde is negating this compound sentence, okay? A negation of a compound is not the same thing as a negation of a simple formula. All right? And that's the parentheses. That's what the purpose of these parentheses, okay? This tilde operates on everything between this parenthesis and that parenthesis, whereas this tilde only operates on this letter right there. All right? All right. You can also build formulas to any degree of complexity, literally an infinite degree of complexity via the 5 operators. So for example, you could disjoin G and B with M and A to get either the Golden Girls is the greatest TV show of all time and Betty White starred on it, or Matlock is the greatest TV show of all time and Andy Griffith starred on it. Additionally, the formula if G then M, which I'll put in parentheses just to show, the formula if G then not M means that if the Golden Girls is the greatest TV show of all time, then Matlock is not the greatest TV show of all time. The formula G if and only if B means that the Golden Girls is the greatest TV show of all time if and only if Betty White starred on the greatest TV show of all time. So you can see how we're combining all these different formulas via the Sentential Operators. My suggestion at this point is just read through Unit 2, do the exercise, so you can get an idea of the literally infinite number of ways that simple formulas can be combined into more complex formulas. All right. Now we need to spend some time, lastly, this will be the last thing we discuss, and it's the major operator. Every formula in logic has a major operator. Remember, a formula is a way of relating 2 different sentences via a sentential operator. Well, every formula has a major operator. So formulas can have literally an infinite number of operators, but there's always going to be a major operator. And that major operator is what's going to determine the overall form of the sentence, and it's going to be the operator introduced last in the process of constructing the formula from its more elementary components. And it'll take some practice to learn how to find the major operator, but it's a skill that you should develop, and if you do everything I say, you will develop it. Okay, let's just start with this formula right here. A and B, A dot B, horseshoe C or D. That literally means A and B, if A and B, then C or D. Well, what's the major operator? It's the horseshoe. The major operator is right there. Well, why is the horseshoe the major operator? I'm going to show you. First off, here's a simple formula. Here's a compound formula. Here's another compound formula, and there's parentheses. All right? So, and then you get a bigger formula with these two combined. All right, here's another compound formula. A and B, horseshoe C or D, or E if and only if F, and not G. All right, what's the major operator? It's this V. Okay, well, there's two different V's. Which one do I mean? I mean the second V right there. Well, how do we know that it's that? Isn't that confusing? I'm going to explain. And we're going to walk through this, but you start with the smallest formulas, and then you kind of work your way out to the biggest. So here's a small formula right there. Here's one parenthesis, and here's the right parenthesis and the left parenthesis. Here's another one right there. Oh, okay, left and right. Oh, and here's another really small one, left and right. Okay, now let's work our way out to one level bigger. Okay, here's the next parenthesis. Oh, goes all the way there, left and right. All right. Well, what about this go out the outer? Nope. We should ignore that for now. How about we start here? Left, and then right. Okay. And then here's the outermost parentheses. Right there. In fact, let me show you another trick to do this. And I'm going to walk through this several times. Just the point is so you can master this. So let's reset it. How are we going to find the major operator? I say you start with the smallest formulas and you work your way out. So here's a very small formula, A and B. Okay. What's the major operator? What's the operator in that? It's that right there. Well, since that's a very small formula, and that's the operator of that very small formula, that can't be the major operator of this big formula. All right? Again, here's another really small formula, enclosed in these two parentheses, C or D. Here's the operator of that small formula, but since it's the operator of that small formula, it can't be the major operator of this entire formula. Again, E, if and only if, remember the triple bar, E if and only if F. That's the operator of this small formula, but since it's the operator of this small formula, it can't be the major operator of this big formula. All right, now let's work our way up one level. The next set of parentheses. Okay, here's one. Here's a left parenthesis, and here's a right parenthesis. So let's join them together. You can do that. You can just draw them. Okay. Well, what's the operator of this bigger formula? It's this horseshoe. But that's not the entire formula, so that horseshoe can't be the operator, the major operator. All right. Another one. Here's this parenthesis, and here's that parenthesis. Okay. Well, what's the operator of that? It's this conjunction symbol, this dot. Well, since that isn't, since that's a small formula, it's not the whole formula, that can't be the major operator. Well, what's left? The only one that's left is this or, this disjunction sign, okay? In fact, if we join these last two parentheses, that is the operator within these two parentheses, but since that's the whole rest of the formula, that's the major operator right there, the second disjunction symbol, the second V. Okay. So the form of a sentence plays the crucial role in logic. It's relevant to validity, so it's important that you learn how to find it. What we just did was we figured out the form of this formula. Here's a formula, and the form was it's a disjunction because of this second V. All these symbols, but this is really this formula. The major form of this formula is just that simple two-place disjunction right there. All right? But finding it, you have to learn how to find it. Well, what's the trick? I just showed it to you, but we'll put it in words. You pair parentheses, starting with the smallest formulas, and then you work your way out to the largest. Anytime you have some parentheses, you'll have an operator. So it's almost like process of elimination. So again, here's a major formula. All right. What's the major operator? Well, we'll start with the smaller parentheses. Right there, C, A and B, C horseshoe D, H dot E. Okay, well, those, by process of elimination, can't be the major operator. All right, now let's work one level out. That or that. That's a disjunction operator. Well, it can't be that. H, and then we have this formula, or C. Well, it can't be this disjunction symbol either. Okay, let's work our way one level out. Oh, see that? There's 3 parentheses here, but there's only 2 here. So this must be one whole formula, and it is. Right there, okay? Well, what's the major operator of that? It's this disjunction symbol, okay? Well, then that can't be the major operator of this whole formula. Well, what does that leave us? It leaves us this horseshoe. It's a conditional then. This formula is a conditional. If, then, literally, if it's that. That is the formula right there. What you're looking at is an if-then statement, a conditional. If all this, then all that. All right? That's the major operator. That arrow should be moved over a little bit. Right there. That's the major operator. Okay. Well, I would practice this with the exercises in the book, and then I'll also have a practice quiz so you can continue to practice that. And this is just the type of thing that just takes practice, and it also just takes being careful, being cautious, being slow, double-checking your stuff. Because if you get the major operator wrong, then you understand the formula wrong. Okay, well, let's wrap up this Unit 2, Part 2 video with some definitions, which are all taken from the book, so nothing's original. A sentence is compound if it logically contains another complete sentence as a component. A simple sentence is simple if and only if it is not compound. One sentence is a component of another sentence if, whenever the first sentence is replaced by any other declarative sentence, the result is still a grammatical sentence. One sentence logically contains another if it either literally contains the other as a component or can be paraphrased into an explicitly compound sentence that contains the other as a component. Finally, a sentential operator is an expression containing blanks such that when the blanks are filled with the complete sentences, the result is a sentence. Great job, everyone. Good night.